All right, so on the first part, we did adding, subtracting, and multiplying, and now we're doing dividing. Okay, this is more complicated than the other three. So when I'm dividing complex numbers, it's going to be presented to me as a fraction. We know that a fraction is really just division. Okay, so this is 2 minus I divided by 3 plus 2I. And part of the problem here is that I have this I in my denominator. Okay, so remember that I is equal to the square root of -1. So this is like having a radical in the denominator. We've done this before in other problems where you have something like 2 over the square root of 3. And we say, oh, this is bad. We have to rationalize, right? So we would multiply top and bottom by the square root of 3. Well, we kind of have to do the same thing here. But because we're dealing with imaginary numbers and complex numbers, it looks a little bit different. Okay, so if I want to get rid of 3 plus 2I in the denominator, this is where I have to multiply top and bottom by the conjugate of the denominator, okay? Because in the previous lesson, if I multiply 3 plus 2I times 3 minus 2I, I know that my answer is going to be a real number, okay? But I have to multiply the top by 3 minus 2I as well, because remember, what I'm really multiplying by is 1. This is 1. So I'm changing the way that this looks, but I'm not changing its value. Okay, so what you can see is going to happen is that you're going to double distribute on the top and the bottom of this fraction, okay? So on the top, we're going to have 2 times 3. That's going to give me 6. 2 times 2I, negative 2I, excuse me, is negative 4I, okay? Negative I times 3, negative 3I. Negative I times negative 2I is going to be positive 2I squared. So biggest thing here, guys, is watch your signs. Okay, then on the bottom, 3 times 3 is going to give me 9. 3 times negative 2I, negative 6I, 2I times 3, positive 6I, 2I times negative 2I is negative 4I squared. Okay, so now I need to simplify stuff down. Okay, so in the top, we're going to combine those terms right there. So this is going to be 6 minus 7I plus 2I squared. Okay, in the denominator, we're going to combine these two, and guess what? Those cancel, and that should happen. That's what happened when I multiplied the conjugates before. That's what I want to happen. Okay, so this is just going to be 9 minus 4I squared. All right, so this is the point where we see these I squareds, and we know that I squared is equal to -1. So we're going to substitute that in. So this is going to be 6 minus 7I plus 2 times -1. And this is going to be 9 minus 4 times -1. Okay, so those get substituted in. All right, so we have 6 minus 7I minus 2 over 9 plus 4. Negative times negative gives me positive. Then I combine those real numbers. So 6 minus 2 gives me 4 minus 7I all over 13. And here we have to split up because my answer has to be in A plus BI form. So you're going to take 4 and divide it by 13. And then you're going to subtract, because this is negative, 7I over 13. And that is my answer. So my answer is in A plus BI form. Okay. And again, if you remember when we did the quadratic formula, that way, if there's something that can reduce here, you can reduce it. And if there's something that can reduce here, you can reduce it. Okay, so it has to be split up in order to simplify, but that is my answer. Okay, so you multiply top and bottom by the conjugate. Then you're going to combine like terms. Then you're going to substitute in -1 for your I squareds. Then we're going to simplify down, combine the real numbers, and separate. All right, let's do another one. Okay, example, 3 minus 4I over 2 minus 3I. Okay, so we're dividing again. We see this I in the denominator. That's bad, so we have to get rid of it. So we're going to multiply top and bottom by the conjugate of the denominator. Okay, it needs to be the conjugate of the denominator to get rid of that I. Okay, so on top, we're going to get 3 times 2, which is 6. 3 times 3I is 9I. Negative 4I times 2 is negative 8I. Negative 4I times 3I is negative 12I squared. Okay, and then over that, 2 times 2 is 4. 2 times 3I is 6I. Negative 3I times 2 is negative 6I. Negative 3I plus 6I, plus 3I, negative 9I squared. Okay, we combine our like terms. So on top, we're going to get 6 plus I minus 12I squared. On the bottom, these two should cancel out. So we get 4 minus 9I squared. Okay, this is where these -1s are going to come in. Okay, so you see how I kind of write mine on top like that? You can do that as well with your pencil. Okay, 6 plus I minus -12 times -1 is going to be plus 12. Okay, and then down here we're going to have 4 plus 9. So we add our like terms, 18 plus I over 13. And then again, we're going to split 18 over 13 plus this time, because this is a positive I over 13, and we're going to leave it like that. Now, this is just purely coincidental that we got 13 again as our denominator. Okay, but in this case as well, if I could reduce here, I would. If I could reduce here, I would. You can leave this as I over 13. You can put a 1 there if you want, but it's perfectly fine to leave it just as it is. Okay. Here's one you can kind of try on your own. Okay, so at this point, I would recommend pausing the video. All right, so if you did this on your own, this is what you should get. Check your work with mine. Okay, and pause if you need to. I'm going to do one last example. All right, last one for the dividing. 20 minus 5i over 2 minus 4i. Okay, so again, go ahead and try this one on your own. Okay, so if you get down to this point, hopefully you were able to do that. Okay, you get down to this point where you separate, and now this is an example of one where we can actually reduce. Okay, so 20 goes into 63 times. And here, those zeros are going to cancel out. You're canceling by a factor of 10, basically. Okay, so your final answer is going to be 3 plus 7i over 2. So that would be my answer for this problem. It's a little bit different because I was able to reduce, but still the correct answer.